Let's try another segment before the break. Then if now I print my stack, let's do this. Let's print stack before and after. Right, before and after. Stack top must return a value. Oh yeah. Oh, I need to say return, right? Return this, not just, expression which does nothing. But once I figured out how to get to the data, return the value back. Now, this is somewhat confusing, but again, you need to be able to parse it just like I did, right? There is an M root. It has the data member, which is a pointer to another node, right here. Each node contains a pointer to another node named pnext. So I go here and I say pnext, right? Pnext, and I say give me the data, right? So I found a way to get to that integer that contains the data. And I return a reference to it from my top. So now if I build this and run it, so as you can see, originally, when first time I say print, it contains 777 on top. After I say store 111 on top, that integer in the list right here, this integer right here in this data element in this node, 777 gets replaced by 111, right? So it does happen. So this happens. So this is a brand new interface to the stack. This demonstrates this idea. So it is common practice to provide two versions of top. Another version of top has a slightly different signature. This version of top is not declared a constant function. It's a non-constant function because it clearly updates stuff inside this entire structure. So it definitely can return a reference which potentially provides access to the internal data and allows the user to store the information. So the second version of it is going to return a copy of something at the top of the list. But because it returns a copy, it can safely be made const, because this version of top cannot be used like this. So then let's do something like this. I'll decorate this a little bit. I don't know, something like that. Well, you know what? No. Let me do it differently. How about this? Integer temp equals stack dot top. How about this? All right. So in one case, I would like to replace and get mutable access to the element, the data element, that integer that is sitting in those on that list. The second time, I just say, hey, just give me the value. Now, when you write this code here in this file in main, what happens here is that you don't know what gets called. You just know that stack documentation tells you that you can use top for both read and write, right? So here's where we're actually writing new value to the top. Here we're just getting value from the top. But this trick of providing two different functions which differ really by this const. Let me compile it. Okay. And then place a breakpoint here. Oh, I should not press F9.